Hello, 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 hello. Okay. So we will continue. Okay. So we will continue the revision. Okay. So we will look at this paper, February, March 2024. Okay. So we already finished all of the 2025 papers that are available. So now we will move on to 2024. Okay. Yep. So for the organic chemistry questions, we will start at question 25. Yep. Okay, so we will start at question 25. Okay. Let's look. Okay. Okay, diagram shows the structure of the naturally um occurring molecule of cholesterol. Okay, cholesterol, no problem. Okay. Student X stated that 17 carbons in the ring all lie in the same plane. Okay. Student Y say that this molecule displays cis-trans isomerism at the CC double bond. Okay. So okay, who is correct? Okay, who is correct? Okay. Um okay, our answer is B. Okay, let me explain why. Okay, hold on. Um, okay. Okay, the explanation is here. Yeah. Okay. Okay, so first we will look at cis and trans alkenes in rings. Okay, so first point they are saying that okay, um, okay, so first the 17 carbon atoms in the four rings lie in the same plane. Okay, so our answer is no. Okay, so can you see this one, a six-membered ring? Okay, the carbons they are not in the same plane. Okay, so they are kind of like up and down. Okay, they are kind of like up and down. Why they do that? Because that is the way they can get this tetrahedral. Yeah, okay. So they can get this tetrahedral arrangement whereby the electrons are furthest away from each other. So we want the least, okay, we want the least repulsion, okay, between the electrons. So we want them to be as far away as possible, okay. So only if they arrange in this way, they can have the tetrahedral arrangement whereby it will be most stable, least repulsion, okay. So that's why we are saying that this carbon, they are not in the same plane. Okay. They are not in the same plane because of this reason. Okay. Yeah. Because in the tetrahedral arrangement, they are more stable. Okay. So the first statement is incorrect. Okay. Second statement, this molecule displays cis-trans isomerism at the CC double bond. Okay. Um, we are saying that they display cis-trans isomerism means they can like this one you can bend to this way, you can bend to this way to get the now this is cis, right? So you can bend it over to here to make the trans. Okay, in reality it cannot happen. Okay, in reality it cannot happen. Why? Okay, let's see. Okay, so the double bond in the cycloalkane like this one, okay, or seven fewer carbon, they are exclusively cis. Okay, so they are always cis. Why? Because the trans isomer are too strained to be stable under ordinary condition. Yeah, okay. So they are always cis. Okay. If you want to have trans, you need to like bend the molecule in a way that is really unstable. Yeah, there will be a ring strain. So you cannot have like this stable situation. Okay. So for this reason, we can omit the cis when naming cyclohexene because the cis configuration is assumed. It's always cis. You don't get trans. Okay. So that's why the second student is incorrect. Okay. They don't have cis trans isomerism. It's always cis because the trans isomer is too unstable. Okay. It's too unstable. So that is the idea for this question. Okay. So our answer is B. Okay. Next. Okay. Drug cortisone has this formula. Okay. In addition to those chiral centers marked by asterisk, we already have 3 chiral center. How many other chiral center? Okay. How many other? Our answer is this. 1, 2, and 3. Okay, so we have 3 other chiral center. Okay, so these are all chiral centers with 4 different groups attached to the carbon center. Okay, yeah. Okay, next. Okay. Okay, butyl react with cold dilute acidified manganate to give product X. Butyl react with hot concentrated acidified manganate to give product Y. Okay. Which statement about X and product X and product Y is correct? Okay. So we'll do it one by one. Okay. So we have cold manganate and hot manganate. Okay. What's the difference? Okay. Cold manganate, what will it do? Okay. Build two in. 1, 2, 3, 4. The alkene is here. And then you add the cold manganate. Okay, so what it will do, this reaction, it will form the diol. Okay, it will add the diol 1, 2, 3, 1, 2, 3, 4. So it will add the diol. Okay, so that is the function of the cold manganate. Okay, how about the hot manganate? Okay, okay, hot concentrated manganate. Okay, so what's the function? The function of the hot manganate is split. Okay, split the double bond. Okay, so we have 3 situations, right? We have 3 situations. This specific situation, okay, let me just quickly show the notes. Yeah, okay, if I'm going like too fast or too slow, you just stop me, okay? If I'm saying something you already know, you can just like stop me and ask me to move on. Okay. Okay. This one. Okay, just in case. Yeah, you see? This one, coal potassium manganate. Okay, dilute acidified potassium manganate. What it will do, it will add the diol. Okay, so it will add the diol. Okay, so for the hot potassium manganate, it will split the double bond. Okay, so depends on the situation. If the double bond one side we have this, it will turn to CO2. If we have one R group, it will turn to carboxylic acid. Okay, so if it has two R group, it will turn to ketone. Okay, it will turn to ketone. So looking at our situation, okay, so this one is one R group. Yeah, okay, one R group, so it will turn to carboxylic acid. Okay, 2 carbon carboxylic acid, both sides the same. Okay, like this, COOH. Okay, 2 carbon carboxylic acid. Okay, so now, which statement about both X and Y is correct? Okay, both product will react with 2,4-dinitro. So this one is for aldehyde and ketone only. Aldehyde and ketone only. So this one no, this one no. Okay, so this is wrong. Okay, this is wrong. Okay, how about this one? Y will react. Okay, so this one is X, this one is Y. Okay, X and Y. Okay, so Y will react with 2,4-dinitro? No. Okay, because it's acid. Okay, X will react with 2,4-dinitro? No, because this is alcohol. Okay, so this is also no. Because the 2,4-DNPH only react with aldehyde and ketone. Okay, so our answer is B. Okay, neither will react. Neither will react. Okay, because they are not aldehyde, not ketone, alcohol and acid. Okay, they are not aldehyde, not ketone, so will not react with the 2,4-dinitro. Okay. Okay, next. Sequence of reaction. Propanoic acid. Okay. So propanoic acid, 1, 2, 3. Like this. Okay. Propanoic acid, lithium aluminum hydride is a reducing agent. So we have reduction here. So we know carboxylic acid normally we will reduce. We will reduce to alcohol. Okay, we'll reduce to alcohol. 3 carbon alcohol. 1, 2, 3. Like this. Okay. Concentrated sulfuric acid. What's the function of concentrated sulfuric acid? Elimination. Okay. Remove the one hydrogen and one OH. Okay, elimination. So here it turns to alkene. Okay, and then here phosphoric acid. Okay, so what is the function of the phosphoric acid? Uh, phosphoric acid with steam. Okay, phosphoric acid is the catalyst. So what we are adding is the steam. Okay, what we are adding is the H and OH. Okay, yeah. So this is our double bond here. So we're going to add the H and OH. Okay, Markov-Nikov rule. Markov-Nikov rule is saying that the hydrogen, okay, you see this one, it has, at first, it has one hydrogen. And then this one, at first, it has two hydrogen. Okay, so this one already has one hydrogen. This one already has two hydrogen. Okay, the third one, it will always add to the one that already have more hydrogen. So it will add to here. It will add to the one that already have more hydrogen. Okay, so it will add to here. Okay, the OH, it will add to the other one. Okay, like this. Okay, so means we end up with something like this. Okay, so this is our product. So our product is propane 2O. Propane 2O. Okay, so this will be the major product according to the Markov-Nikov rule. Okay, the hydrogen will always add to the one with more hydrogen. Okay, so that's the idea. Because that will give a more stable carbocation. It will give a more stable carbocation. Okay. Okay, next. Okay. Which statement is correct? Which statement is correct? Okay. Bromoethane react with sodium hydroxide to form ethene as a major product. Okay. This one is elimination. Elimination, we must put ethanolic. Okay. Ethanolic sodium hydroxide. Yeah. Okay. So if we want to do elimination, bromoethane, like this. Okay. Bromoethane turn to hold on. Okay, only 2 carbon. Okay, bromoethane elimination, okay, to form the ethene. Okay, the condition must be ethanolic sodium hydroxide, ethanolic, not aqueous. Okay, so if we have aqueous, what happens is nucleophilic substitution. Nucleophilic substitution. Okay, if we have aqueous sodium hydroxide, this one must be ethanolic. Okay. Okay. So different solvent will give different result. Okay. So this is incorrect. Okay. Um, 1-chlorobutane react more rapidly than 1-bromobutane. Okay. Um, okay. So this one, it depends on which bond is stronger. Okay. Which bond is stronger. Okay. So chlorine, okay, is smaller, the atom. Bromine is larger. Okay. So the bond with carbon, okay, so this one is a longer bond. Okay, longer bond means it is a weaker bond. Okay, so if it is a weaker bond, it's easier to break. Okay, it's easier to break, so means it's faster. Okay, so we are saying that bromobutane is faster. Okay, so it will react faster. So the chlorobutane will be slower. So it's saying more rapidly. So this is incorrect. Okay. Okay. Hydrolysis of C2H5 and then CBr occurs mostly the SN2 mechanism. Okay. Let's see this the structure. This structure is like this. Okay. So carbon with 3 ethyl group. Okay. 3 ethyl group C2H5 and the Br. Okay, so this is tertiary. Okay, so tertiary is very crowded. Okay, so it's very crowded. So what it will do, the Br will leave first. Okay, the Br will leave first. So we have the carbocation, and then the nucleophile. Okay, the nucleophile comes along. Okay, so that's how it happened. So this is actually SN1. Okay, this is SN1 mechanism. SN1 mechanism because you only need one molecule to start the reaction. Okay, this is what we call SN1 mechanism. Okay, so for SN2 mechanism, we need two molecules to start the reaction whereby we have the transition state. Okay, we have the transition state. So this is no. Okay, this is SN1 because we just need this to break. Okay, we only need one molecule to start the reaction. So this is SN1. Okay, not SN2. Okay, next. So this is also incorrect. Okay, so the answer should be D. Why? Okay, so let's see. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So this carbon, like this. Okay, so this is a carbocation. Carbocation, this is primary. Okay, this is primary. Only attached to one other carbon. Okay, this one is like this. Okay, CH3, CH3, CH3. Okay, like this. This is connect to three other carbon. This is tertiary. Okay, so we know the tertiary one is always more stable. Okay, and then the primary one is less stable. Okay, Primary is less stable. So primary less stable than tertiary. Yes, correct. Okay. Answer is D. Okay, next. 30. Okay, hydrolysis of bromoethane by aqueous sodium hydroxide. Okay, bromoethane, 2 carbon, and then bromine. Okay. And then we have the nucleophilic substitution to form the OH. Okay. So the attacking group, okay, is the, okay, so this is nucleophilic substitution. Okay. Nucleophilic substitution, which means we must be having a nucleophile. We must be having nucleophile. So the attacking group must be a nucleophile. Okay. The one that attack. Okay. So the leaving group is the bromide. Okay. How about the bromide? Is it nucleophile or electrophile? The answer is nucleophile. Okay. Why? Because if we do the reverse reaction, now the bromine is the nucleophile. Okay. So the reaction can happen reverse direction. Okay. When it happens reverse direction, now the Br becomes the nucleophile. Okay. Yeah. So why we say that these are nucleophile? Why? Because this carbon. Okay, hold on. Okay. Because this carbon, this delta negative, delta positive. Okay. So when we have a positive center is nucleophilic reaction. When we have a negative center, like the double bond, this is electrophilic reaction. Okay, so that's why we are saying that they are both nucleophiles. Okay, so this one, we have this carbon center, means it is a nucleophilic reaction. Again, this one, again, we have the carbon center, positive carbon center. So this is also for nucleophilic reaction. Okay, 31. Okay, X is organic compound containing the elements of carbon, hydrogen, and oxygen only. Okay, the tables show observation made from 3 chemical tests carried out on X. Okay, so react with sodium effervescence. So means there is a reaction. Okay, so the one that can react with sodium will be alcohol and acid. Both can react. Okay. Excuse me. Excuse me. React with sodium carbonate. This one is acid only. Okay. Okay. Hot dichromate. This is oxidizing agent. Okay. Oxidizing agent. Remain orange means no reaction. Okay. No reaction means it cannot oxidize. Okay. It cannot oxidize. Okay. So what situation we cannot oxidize? Okay. Tertiary alcohol. Okay. Tertiary alcohol cannot oxidize. And then acid cannot oxidize. And then another one is ketone. Okay. So these 3 things, they already fully oxidize. Cannot oxidize further. Okay. Now, which one can fulfill our condition? Okay, which one can fulfill our condition? Okay, eh, okay, hold on. Okay. Carried out on X. test carried out on X. Okay. So this one, okay. Oh yeah. So this one, it has secondary alcohol, okay, which can oxidize. Okay, so it can oxidize, but we are saying that X cannot oxidize. We are saying that X cannot oxidize, but we have this secondary alcohol that can oxidize, so no. Okay. Um. Okay, this one is aldehyde. Okay, this part is aldehyde. Okay, so aldehyde, it can oxidize to acid. It can oxidize. Can oxidize. Okay, but we are saying that this one, the X, it cannot oxidize. So this also no. Okay, so here, we, yeah, and then we also have this secondary alcohol. It also can oxidize. So no. And then here, we have this aldehyde again. Okay, so this aldehyde can oxidize. Okay, so also no, because X cannot oxidize. Okay, let's see. So this one is the answer. Why? Because we have the acid, okay, that cannot oxidize further. Okay, and then we have this alcohol. This is a tertiary alcohol. Okay, um, which also cannot oxidize. Okay, the tertiary alcohol also cannot oxidize. Yeah, so we can check one by one. Okay, sodium can react or not? Yes, because it got acid, it got alcohol, can react. Sodium carbonate, sodium carbonate can react or not? Yes, because it can react with the acid. This one, oxidizing agent, it cannot react because the acid cannot react. The tertiary alcohol also cannot react. So answer is D. Okay, answer is D. Okay, next. Okay, 32. How many moles of oxygen gas are needed for complete combustion of this? Okay, complete combustion. So this one, if we so we need to write the full equation. Okay, we need to write the full equation. Okay, so this one, if we combine everything, we find that this is C4 H10 and one oxygen. Okay, C4 H10 one oxygen. We need to check how many oxygen molecules, how many moles of oxygen gas, okay, to form the CO2 and water. Okay, so we can see here this is 4 carbon. 4 carbon. So suppose we have 4 CO2 here. Okay, hydrogen is 10. So means we have 5 here. Okay, so here we have 4 times 2, this is 8 oxygen. Okay, and then 5 times 1, this is 5 oxygen. So total, this is 13 oxygen. Excuse me. So here we already have 1 oxygen. So means here we need 12 oxygen. 12 oxygen equivalent to 6O2. Okay, 6O2. So our answer is A. Okay, answer is A. Okay, next. Okay, which pair will each compound give a different visible result with the alkaline I2? Okay, alkaline I2. So alkaline I2 is two situation. alcohol when we have this group. Yeah, when we have this situation for alcohol, and when we have a ketone, some kind of ketone, okay, like this, and then we have this. Okay, so this is a first situation. Second situation, ketone. Okay, and the third situation is ethanol. Okay, ethanol. Okay, this. Okay, ethanol, it looks like this. Okay, two carbon, and then aldehyde, like this. Okay, so again, we have this. Okay, so these three situations are active for alkaline I2. Okay, so these three situations will be active for alkaline I2. So we will check one by one. Okay, so this one, okay, this one is alcohol, normal alcohol. 1, 2. Okay, so this one will be a normal alcohol. Uh, like this. Okay, so this one does not have these three situation. Okay, these three situation, no. So this one will be inactive. Okay, inactive. Okay, so this one is the ethanol. This is the ethanol. Okay, this is ethanol. So this one, it will be active. So this is yes. Okay, so we can straight away see our answer is A. Why? Because different result. This is no, this is yes. Okay, so our answer is A. So we'll check one by one. This is also ethanol. This will be yes. This one is this propanol. So propanol, it has this group here. So this will be yes. This is yes, yes. Okay, so we don't want. So this one, we want. This one, we don't want. Okay, we want yes, no. Okay, this one is acid. Okay, so acid also not active. Okay, so acid is not active. Okay, and then this one, a okay, this one is like this. Okay, 1, 2, 1, 2, like this. Yeah, okay. So this one also, we don't have the metal ketone. Okay, we don't have this group here. No. So this one is no, no. Okay, and then this one is aldehyde, but 3 carbon. 1, 2, 3, and then like this. Okay, we also do not have these three situation. No. Okay, no, no. Okay, so this is no, 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 yes, yes. Okay, so these are all incorrect. Okay, incorrect, incorrect, incorrect. What we want is this. Okay, no, yes. Okay, we want different visible result. We want different result. Okay, yeah. So that's the one. Okay, next. Um. Okay, next. 34. Okay, which reagent will give a positive result with propanol? Propanol. Okay, so we'll see one by one. Okay, So this is ketone. Okay, propanol is ketone. Tolerance reagent, remember, tolerance reagent and Fehling reagent, they are active for aldehyde only. Okay, so this is no and no. Okay, aqueous bromine is for alkene. Okay, adding on alkene only. Okay, like any alkene group. Okay, it's just addition. Okay, only for alkene. So this is also no. Our answer is alkaline I2. Okay, alkaline I2. Why? Because we know alkaline I2 is active for this metal ketone group. Okay, so this one, it will give a positive result. Okay, okay, 35. Okay, esters can be hydrolyzed with aqueous alkali or aqueous acid to form two products. Okay, yeah, any ester, like example, like this, like this. Okay, so this is the ester bond. So if we break it, we will get acid on this part, and then we'll get alcohol on this part. Okay, so if we have acid situation, if we have acid condition, this one, it will turn to like this, carboxylic acid. 1, 2, okay, like this. Okay, forms equilibrium mixture between organic acid and alcohol. Okay, this one. Okay. But if we have alkali condition, we can form this 1, 2. Like this. Okay. It will form the salts. Okay. So let's say we put like sodium hydroxide. It will form this salt. Okay. Complete conversion to salt and alcohol. So our answer is C. Okay. You see this one, the product is still there, so it can undergo um um reversible reaction. So we will have equilibrium. Okay. But if we form the salts, we remove the product. Okay. We remove the product, so it cannot have a reversible reaction. So it will go to a complete conversion. Okay. It will react completely. Okay. Next. Okay, structural isomerism only should be considered when answering this question. Okay, so we only focus on structural isomerism. Okay, quick reference to the notes. Okay, what it means by structural isomerism. Okay, this one. Chain, like example, 1, 2, 3, 4, 5, like this. 1, 2, 3, 4, like this. Okay, so this is chain isomerism. Okay, position isomerism is like this. Okay, okay, like the OH, either we put here or we put here. This is positional isomerism. Functional group is like same molecular formula, but it can be ester or acid. Okay, so this is functional group isomerism. Okay, stereoisomerism is geometrical, cis trans, and optical. Okay, the one with the chiral center. Okay, so okay, back to the question. Okay, we are only considering structural isomerism. Okay, structural isomerism means we only focus on this part. Okay, just on this part. Okay. Okay, C5H11Br. Okay, so we expect, okay, the functional group, nothing, because we only have one functional group, which is the Br. So which means we expect these two. Yeah, these two. Okay, so we're going to consider all of the possible answers. Okay, all of the possible answers. So first, okay, we just have the straight chain, which is 1, 2, 3, 4, 5, and then BR. Okay, so this is the first one. And then we're going to have one branching, 1, 2, 3, 4, like this. Okay, and then this metal group we can put here, we can also put here. Yeah, okay, so this is different. Okay, and then another thing we can do is we can do like this. Okay, we can do like this. Uh, 1, 2, 3. Okay, okay. 1, 2, 3, 4, 5, and then BR. Okay, so our answer is 4, like this. Okay, yeah. So this is our answer. Okay. Oh, yeah, yeah, yeah. And then another thing, they are only asking for primary. They are only asking for primary halogenal alkane. So which means this carbon, okay, must be primary. Okay, this carbon must be primary. Okay, like this. Okay, it only attached to one other carbon. Okay, it only attached to one other carbon. Okay, okay, which means this is no. Okay, make a mistake there. Which wait, if it's not this one, what else can it be? Um, oh, I know. Wait. Uh, okay, they must be primary. Okay, so this is primary. Okay, this is primary. This is primary. Okay, this is not primary. Oh, sorry. I put at the wrong position. Okay, not here, not here. Okay, like this. Okay, this is 1, 2, 3, 4, 5. Okay, like this. 1, 2, 3, 4, 5. Okay, so this 1, 2, 3, 4, 5, like this. Yeah, okay. So this is the primary carbon. Yeah, okay. So they must be primary. So they are all primary. All attached to one other carbon only. Okay, attached to one other carbon only. Okay, yeah. So this is the idea of the primary. Okay, answer is A. Okay, okay, 37. Okay, so this one, okay, we're starting with the uh bromoalkane, bromoalkane reaction with the KCN. So we know that this is a nucleophilic substitution. Nucleophilic substitution. Okay. Nucleophilic substitution is like this. Okay. CH3, CH2. Now it turns to Cn. Okay, substitution. Okay, reflux with dilute hydrochloric acid. Okay, so what's the function of the dilute hydrochloric acid? Is to convert this into acid. Okay, so that's the function. Okay, COOH. Okay, convert to the acid. Okay, so compound Z. What is compound Z? This one. Okay. Yep. So that's the product that we expect. Okay. So starting with 2 carbon, because we are adding the CN here, the nitrile group, we end up with 3 carbons in the end. Okay. Okay, next. Okay, hydroxyethanol. Okay, hydroxyethanol. So means we have 2 carbon like this. Okay, 1 carbon is like this, OH. Okay, and then the other one is like this. Okay, one side is alcohol, the other side is aldehyde. Okay, heated under reflux with excess acidified potassium dichromate. This is oxidizing agent. Okay, oxidizing agent. So when we have alcohol oxidizing agent, it will turn to acid. Okay. When we have aldehyde group, we have oxidizing agent, it will also turn to acid. So we end up with both side, it becomes acid. Okay, both side become acid. Um, so this is incorrect. Okay, this is incorrect because both side will become acid. So A and B, which one is correct? Answer is B. Why? Because we only have 2 carbon. Only 2 carbon. So this one is 3 carbon. This is incorrect. Okay. So we only have 2 carbons. Okay. Next. Okay. 39. Repeat unit of addition polymer. Okay. What is the correct name of the monomer? Okay. Yeah. So it's always like a little bit confusing. Okay. So it's kind of like this. Okay. And then like this. So our repeat unit is like this. Okay. 2 carbon and then hydrogen, hydrogen, and then the CH3 and the CH2, CH3 like this. Okay. So in the end, we have uh 1, 2, 3, 4, 5, 5 carbon. 1, 2, 3, 4, 5. And then the double bond at the second carbon. Okay. So our answer is pentoene. Okay. So it's actually pentoene. Okay. Yep. Okay. Next. Okay. So we have infrared spectrum. Okay. Infrared spectrum of this compound here. Okay. Which functional group could the compound contain? Okay. Which one? Okay. We can take a look quickly. Okay. Um, okay, let's take a look. Okay. Okay, so we'll look at the obvious ones. Okay, like this one. Okay. 1,700. Okay, 1,700 is this one here. Uh this. Okay. This one. Okay. C double bond O. Okay. C double bond O. And then this one is around 1250, something like that. Okay. So this one is actually this. Okay. So this is the CO. Okay. So which is telling us what could be the answer. Okay. Okay. What could be the answer? Okay. Alcohol. Alcohol is OH. So it got the CO only. Okay. CO only. So it's no. Carboxylic acid is got like this. Um, CO. Okay. And then OH. Okay. So carboxylic acid actually is got both. Okay. It's got both. Okay. A how about ester? Ester. Okay. Like this. Like this. Okay. So it also got both. Okay. It also got both. Okay. Both and then both. Okay. Nitrile. Okay. Nitrile is like CCN. Okay. So this one don't have. Okay. So we already eliminate nitrile and alcohol. Carboxylic and ester. Okay. Carboxylic and ester. Okay. Let's see. Um. Okay. How else can we determine? Okay. What else is there? Okay. So here. Okay. So we got this. Okay. For 3,000. Okay. So this one is at 3,000. Okay. 2,500 to 3,000. Okay. So this one is carboxyl. Okay. Carboxyl OH. Okay. Carboxyl OH. Okay. What is it referring to? Okay. What is it referring to? A Okay. So this is OH. Okay. And then um another key point that we had. Okay. Hydroxy ester. Okay. Hydroxy ester means this is alcohol. Okay. Or ester. Okay. This is alcohol or ester. Okay. But we already eliminate alcohol. So this one, okay, is referring to the ester. Okay. But not for the carboxylic acid. Okay. Not for the carboxylic acid. So which means our answer is the ester. Okay. So the CO for the ester. Okay. So our answer will be C. Okay. So that's how we determine. Okay. So this is done. Okay. Okay. Next one. Okay. February, March 2024, paper 22. Okay. Okay. We only focus on some of the questions. Okay. Only organic chemistry. Uh, wait. Okay, 2D, 2D. Okay, okay, actually we can do this also. We can do this. Okay, oxidizing agent that is similar to potassium manganate. Okay, so here we have alcohol. Okay, we have alcohol. And then okay, explain the term oxidizing agent. Okay, explain the term oxidizing agent. Okay. Yeah, I forgot this one. Okay, so actually we can do this one also. 2024. Okay. And let's take a look. Okay, so what it means by oxidizing agent? Remove electrons. Okay, remove electrons from another or causes electron loss or gain electrons. Okay. Okay. Yeah, so this is oxidizing agent. Compound X form, okay, compound X form when metal butene react with potassium manganate. Okay, metal butene. Okay, 1, 2, 3, 4. Okay, metal butene react with potassium manganate. Okay, so potassium manganate, we are adding the diol. Okay, so we are adding the diol, no problem. Okay, state the essential conditions for this reaction. Okay, so this is cold potassium manganate, right? Cold potassium manganate. Okay, cold and dilute. Okay, so this is the condition. Must be cold and dilute. We will get the diol. Okay, complete the table to show what is observed when X and Y react separately. Okay, so we get these two products. Okay. Um, okay, Y and Z. Okay. So Y and Z. Okay, so this is ketone. Okay, so this is aldehyde. Okay, so reaction with the sodium carbonate. So sodium carbonate, it react with acid only. Okay, so aldehyde ketone should be no reaction. Okay, no reaction. Okay, um alkaline I2, it will be uh what is observed. Okay, what is observed. So for alkaline I2, what is the observation for alkaline I2? So first, we are saying that there is a reaction. Yes and yes, there is a reaction. Why? Because we have this metal ketone. Okay, so both of them have. Okay, so later we will look at the observation, but we know that there will be reaction. 2,4-DNPH, it react with both, okay, aldehyde and ketone, both react. So our answer also yes and yes. Okay. Later we'll look at observation. Okay, tolerance reagent is aldehyde only. Aldehyde only. So this one, the ketone will be no reaction. This one will be having the reaction. Okay. So first we need to know whether there is reaction or not. Secondly, we need to know the observation. Okay. So let's take a look. Yes, yes. Okay. So this one. Okay. So what we expect, like this. Okay. So the first one, there will be no reaction, no reaction. Okay. Alkaline I2 is yellow precipitate. If it is positive result, there will be yellow precipitate. Okay, 2,4-DPNH. If it is positive, there will be orange. Okay, orange precipitate, orange precipitate. Okay, tolerance reagent. So we know this one, it got no reaction, no reaction. We put no reaction. This one, okay, will be the silver mirror. Okay, so need to memorize all of them. Okay, construct equation for reaction of Z with um uh sodium borohydride. Okay, so Z is the aldehyde. Okay, so Z is the aldehyde. Okay, so this is CH3 CO H like this. Okay. Okay, 1, 2, 3, 4. 4 hydrogen, 2 carbon, 1 oxygen. Okay. Okay, C2H4O. Okay. Okay, C2H4O. Okay, kind of like this. Okay, so we're going to reduce it. Okay, so we're going to reduce it, and our product is the alcohol. Okay, like this. Um, okay, so what actually happened? Okay, what actually happened? Okay, this carbon here, it add. Okay, so it already have one hydrogen to start with, and then it's adding another one hydrogen, and then it's adding another one hydrogen here. Okay, so that's the concept. Okay, so if we look at the equation here, okay, we will find that here, okay, it's adding two hydrogen. Okay, so that's how we figure out it's adding two hydrogen to get the alcohol. Okay, we identify that it's adding this hydrogen here and this hydrogen here. Okay, so it's already have one hydrogen to start with, and then it's adding another one hydrogen, and then it's adding another hydrogen at that oxygen there. So in total, we are adding two hydrogen. Okay. Okay. So this one should be unrelated. Okay. Okay, more organic chemistry question. Yeah, this one. Okay, 2D. Okay, 2D. What's happening here? So we have alkene. Okay, Cl2 means we have electrophilic addition. Okay, electrophilic addition. We are adding something here. Okay, and then how about here? Okay, so here suddenly we get back this double bond. Okay, so what actually happened? This is, excuse me, elimination. Okay, elimination, but we are not eliminating the two carbon. We are eliminating one hydrogen and one chlorine. Okay, so this is what we are eliminating. Okay, next. Show mechanism for the reaction of the Cl2 with propene. So we need to show the mechanism for this step. Okay, so we know this is electrophilic addition, right? Okay, so this is electrophilic addition. Okay. Electrophilic addition. Okay. So this one, okay, we have delta positive and delta negative. Okay. So although it's non-polar, it can have instantaneous dipole. Okay. Instantaneous dipole at one moment, it can be there can be charge separation. And then another reason is because this part is delta negative. So it will induce the delta positive over there. Okay. Yeah. So what happened is this. Okay. One pair of electrons come to there to form a bond. Okay. To form a bond. Okay. So the question is, this chlorine, it will add to which carbon? Okay, so that's the question. Okay, it will add to this carbon or this carbon. Okay, our answer is it will add to this carbon. Okay, it will add to this carbon. Okay, it will give us like this. Okay, wait. Okay, okay. So it already have two hydrogen to start with. Now we are adding the chlorine at here. Okay, we are adding the chlorine at here. And then this one, it has the CH3 and then the hydrogen. And then now it is the carbocation here. Okay, so this one is a secondary carbocation. Carbocation. Okay, what if we add the chlorine at here? What will happen? Okay, what if we add the chlorine at here? We will have something like this. Okay, so this one, we already have two hydrogen to start with. This one, we have the hydrogen and the CH3. Okay, so if we add the chlorine here, we'll get this. Okay, so what is this one? This one is a primary. Okay, primary carbocation, which is less stable. Okay, so we are saying that this will not happen. This will not happen. This is the one. Okay, so this is the one that will happen, which is more stable. Okay, so we also need to like give the correct intermediate. Okay, we need to give the correct intermediate to get the full marks. Okay, so now what happened? So we have this carbocation here. Now the okay, wait, just now we also have another step, which is this. Okay, so what happened here? We have this chloride. Okay, this chloride ion. Now it's got a pair of electrons that can bond with the carbocation, which give us the final product. Okay, yeah. So that's the idea. Okay. Yep. Okay. So this is from the marking scheme. Okay, which is the same thing, but we need to be very, very careful to make sure we give the correct intermediate. Okay, so this is the correct intermediate, which has the more stable secondary carbocation. Okay. Okay. Reagents for reaction 2. Reagents for reaction 2. So this is elimination. Okay. We want ethanolic. Okay. Ethanolic sodium hydroxide. Okay. Ethanolic sodium hydroxide and heat for the elimination to happen. Okay. Okay, next. Draw one repeat unit of the addition polymer that forms from L. Okay, let's see. Oh yeah, okay, so this is L. Yeah. Okay, this is L. Okay, so which means our monomer is like this. Okay, Cl and the metal group, and then we have the hydrogen here. Okay, so the repeat unit, it will look like this. Okay, yeah, okay. So the repeat unit, it will look like this. Yep, straightforward. Okay, next organic chemistry question. Okay, question 4. Yep. Okay. Compound S is used in food flavorings. Possible synthesis of S is shown. Okay. In figure 4.1. Okay. So we are starting with this alkene here. Okay. So HBr will be electrophilic addition, right? Electrophilic, okay, addition. Okay, so that will give us this. Okay, adding the HBr. Okay, no problem. Okay, and then KCN in ethanol is nucleophilic substitution. Okay, nucleophilic substitution, substituting Br with Cn. Okay, and then adding acid, okay, is converting the nitrile group to carboxylic acid. Okay, yeah. So this is the next step. Okay. Yeah. Okay. So this is the progress of the reaction. Okay, no problem. PQRS shows stereoisomerism. Okay, so stereoisomerism means cis trans, okay, or chiral. Okay, no cis trans because no double bond, so should be chiral. Okay, identify with a tick. Oh yeah. Have. P is cis trans. Okay. The rest will be optical. Okay. Okay, PQRS. Okay, let me just highlight. Okay, PQRS. Okay. Okay. Okay, let's look at P. Okay, cis trans have, right? So it's got cis trans because of the double bond. Okay, optical, no. Optical don't have because no chiral center. Okay. How about Q? Q, um, optical, yes. Ge- um, geometrical, no. No double bond. Okay. So this will be no. Okay. Because no double bond, no double bond, no double bond. Okay. But optical, yes. This is the chiral center there. Okay. And then this one also, yes. Chiral center here and chiral center here. Okay. So this will be yes. For the optical. Okay. Yes. Okay. Geometrical is only P. Okay. Okay. Structural formula of Q. Okay. Next question. Okay. Give the structural formula of Q. So this one is the skeletal. Skeletal, but they want structural. Okay. So we will reconstruct it one by one. Okay. So this part is CH3. This part CH2, and then this part is CHBr. Okay, CH and Br, and then finally CH3. Yeah, okay. So that's the idea. Okay, so we should be able to convert skeletal to structural and structural to skeletal. Okay, name the mechanism in reaction 2. Reaction 2, we're going from Br to Cn. Br to Cn, we already mentioned nucleophilic substitution. Okay, nucleophilic substitution. Okay, so only when we have the double bond is electrophilic. Okay, so the other one will be nucleophilic substitution. Okay, complete the reaction for reaction 3. This one. Okay, reaction 3. So we are starting from this one and then we end up with this one. Okay. So now we need to um, convert to the reaction. Okay. So what is actually happening there? Okay. Um, let us quickly refer to the notes. Okay. Um, on. Okay. Let's see if I can find it. Okay. Um, okay, not here. It should be. Okay, let's try this. Okay, how it happened. And okay, okay. Yes, yes, yes. Yeah. Okay. So if we have the nitrile group, okay, how it turns to the carboxylic acid. Okay. So we need to add 2 water molecule, okay, and then 1 hydrogen. Okay. So basically it balance out. Okay. So yeah, we just need to memorize the products, the reactants and products for this reaction. Okay. A okay. Uh this is actually a little bit different without OH. Okay, let me find one. Um should be here. Okay. Ah, yes, this one. Okay. So when we have the nitrile group, okay, so how it convert to COOH? Okay. Nitrile group, how it convert to the COOH. So we will add 2 water, acidic condition. Okay. Um, and then we end up with the acid and the ammonium group. Okay. So how it works? Okay. So first, the nitrogen is removed. Okay. So we remove the nitrogen, and then the nitrogen will take this 4 hydrogen. Yeah, okay. So the nitrogen will take this 4 hydrogen, and then the carbon will take the 2 oxygen and the proton. So that's how we get this product here. Okay. So we just need to memorize. Add water, acidic condition, and in the end form the ammonium ion. Okay. Yep. Okay. So the number of carbon remain the same. C4, C4. Okay. C4H9, C4H9. Okay. So just need to memorize this part here. Okay. Okay. Next. Compound S and T react to form organic compound U, which has a single functional group. Okay. Yeah. So as soon as we see this, we know that it's going to be most likely is ester. Okay. Acid plus alcohol from the ester. Okay. Most likely this situation. Okay. So we have some data for the mass spectrum of U. Okay. Mass spectrum of U. Okay. So we have this. Okay. So given this information, we will use the formula. Okay. We will use the mass spec formula like this. Okay. Excuse me. Um, okay, this one. Okay. We'll use this formula. So it can enable us to work out number of carbon. Yeah. Okay. So if we input here 0.55 and then here 7.2, okay, so that will give us 6.94, means we show that it's 7 carbon atoms. Okay, 7 carbon atoms. Okay, so we know that the product U, it has 7 carbon, and then here it already have 5 carbon. 1, 2, 3, 4, 5. Okay, so which means this one is 2 carbon. Okay, this is 2 carbon. So if we think that it is alcohol, it should be 2 carbon alcohol. Okay, 2 carbon alcohol like this. Okay. Um, okay, so here we have infrared spectrum of U. Okay. Um, identify the functional group present in U. Okay. So U, it should be um like this. Okay. Um, okay. So it's a 7 carbon ester. Okay. So it's going to be like this. 1, 2, 3, 4. Then like this. C, O, and then O. Uh, like this. Okay. So this will be the U. This is the ester. Okay. So now, what kind of peaks we expect to find, okay, in this ester? Okay, what kind of peaks we expect to find? Okay, okay, what kind of peaks we expect to find in the ester? Okay, let's see. Okay, is this what functional group present and explanation? Okay, okay, this one. Okay, so let's see whether we can match it up. Okay, so we have the ester functional group and then which absorption we expect. Okay, 1040, 1300. This one. Okay. Um, okay, this one, which is 1040, 1300, which indicate the CO. Okay. And then 1710, 1750. Yeah, okay. So for ester, okay, this one. 1710, 1750 for the C double bond O for ester. Okay. Yeah. So these are the two main absorptions that we are um interested in. Okay. So these are the two. Okay. So this is how we prove that it is ester. Okay. With these two peaks. Okay. Okay. Next. Okay. T also has a single functional group. Okay. T. Okay. Yep. So just now we already mentioned about T. T should be the 2-carbon alcohol. Yep. Draw the structures. Okay, this one. 2-carbon alcohol. So yield will be after we combine these two into an ester. Okay. Like this. Okay. Yep. Okay. So this is the ester bond. This is the alcohol part. I mean the acid part like this. Okay. And then this is the alcohol part. Okay. So we just need to make sure we have the correct number of carbons. Okay. Correct number of carbons. Okay. This is done. Okay. Okay. Next one is this paper here. May, June 2024. Okay. May, June 2024. Paper 11. Okay. So we will start at question 25. Question 25. Okay, okay. Okay, so this is quite a tricky question. We can take a look. Okay, structural isomerism and stereoisomerism should be taken into account when answering this question. Okay, um, so this structure of 3-methyl cyclobutene, no problem. Okay, a mixture containing all stereoisomer of 3-methyl cyclobutene is treated with HBr. Okay, no problem. This produces a mixture of isomeric bromo metal cyclobutenes. No problem. Okay. How many stereoisomers does 3-methyl cyclobutene have? And how many isomeric um bromometal cyclobutenes are present. Okay, so first we will look at this cyclobutene. Okay, so we want to know these cyclobutenes, how many isomers? Okay, our answer is 2 because it's got this chiral center here. Okay, so this is a hydrogen. Okay, so it's got the chiral center there. So it's got 2. Okay, 2 optical isomer. 2 optical isomers. Okay. Okay, next. So now after we added, okay, after we added the HBr, what happened? Okay, after we added the HBr, what happened? Okay, so the HBr can be added like this. Okay. Um. Okay, so this one is got 2 hydrogen. Okay, so this one got 2 hydrogen to start with. This one got 1 hydrogen to start with. Okay, so now okay, so to simplify things, we do like this first. Okay, so hydrogen, and then 2 hydrogen, and then this one already got 1 hydrogen to start with. Okay, and then we are adding the HBr. Okay, wait. Okay, we are adding the HBr, adding the HBr. Okay, like this. Okay. Um. Okay, so let me draw the. Okay, what we starting with. Okay, so this is what we starting with. Okay, and then this is after we add the HBr. Okay, so the HBr we can add in 2 ways. We can add like this. Okay, we can also add like this. Yeah, okay. So we can add in 2 ways. Okay. Um. Okay. We will focus. Okay, to make things like more clear. So this is a metal group, CH3, CH3, CH3. Okay. Yeah. So okay. So this one just now we say this is a chiral center. Okay. And then here we have a new chiral center here. Okay. But now we are saying these two, they are non-chiral. Non-chiral. Why? Because of the symmetry of the molecule. So if we draw it like a simplified version, we will get like this. Okay, so it's like symmetrical. Okay, symmetrical. So it's actually non-chiral because these two sides they are the same. Okay, so we are saying that this is non-chiral. Okay, so this one it only have geometrical. Okay, so this one it only have a geometrical isomer. Okay, so means it got cis and trans. Okay, cis and trans. Okay, how does it work? Okay, how does it work? Okay, let me show. Um, okay, so we have these 2 groups. Okay, we will focus on these 2 groups. Okay, so if we have this cyclic, okay, cyclic molecule, it's going to look like this. Okay, something like this. Okay, we can see the Br and the CH3, they are opposite to each other. Okay, So it will be something like this. Okay. The isomer, it will be something like this. And then okay. Okay, so this is a cyclic, okay, hydrocarbon. Okay, drawing the 3D structure. Okay, now if we focus on the Br and the CH3, okay, what can happen? We can have the cis Br CH3 like this, okay? Or we can have the trans Br CH3 like this, okay? So these are the first isomers, okay? First isomers. Okay, so this is cis, this is trans, okay? So we can draw out the rest of the hydrogen. So we have the hydrogen like this, okay? Like this, okay? And then this one, we still have this hydrogen, okay? Yeah. So they do not matter because they are the same, okay? No problem. So these are our first two isomers, okay? Hold on. Okay. Let me show the answer first. Okay, our answer is 6. Okay, we have 6 isomers for the product. Okay, so this is number 1. Okay, hold on. Number 1, number 2. Okay, how about this situation? Okay, this situation we have 2 chiral center. Okay, we have 2 chiral center here and here. Okay, so we have 2 chiral center, and then we have like other situation. We also have this cis trans situation. Okay, we also have the cis trans situation, which is like this. Okay, so in a simple term, it's like this. We have Br and the CH3 like this. Okay, so if we draw out the isomers, it's going to be like this. Hold on. Okay, and then we have this. Okay, both of them up. Okay, we also have another situation, one up, one down. Yeah, like this. Okay, okay, okay. So this one is both of them up. Okay, go on. Okay, this one up and then up. This one up, down. Okay, so this one will be cis. This one will be trans. Okay, so the rest will be hydrogen. Okay, hydrogen and hydrogen. Okay, yep. And then because of the chiral center, each of them will be times 2 optical, and then will be times 2 optical. Okay. So yes. Okay, will be 3, 4, 5, 5, 6. Okay. So total, our answer will be 6. Okay. Yep. So that's the idea. Okay. Okay, next. Okay, structure of X. Okay, how many sigma bonds? Okay, so let's draw the full structure. Um, like this. Okay, okay, okay. How many sigma bond? Okay, all the single bonds are sigma bond. 1, 2, 3, 4, and then the double bond 5, and then this one 6. Okay, so the answer is 6. Okay. What kind of hybridization? This one is SP because the bond angle is 180 degrees. Okay. This one SP2 because the bond angle is 120. Okay. Bond angle 120 is SP2. SP3 is 109.5. Okay. So our answer is SP and SP2. Okay. So answer is C. Okay. Okay, next. Okay. Skeletal formula of citric acid. What's the molecular formula? Okay. How many carbon? 1, 2, 3, 4, 5, 6. Okay. Hydrogen. 1, 2, 3, 4, and then 5, 6, 7, 8. Okay. 8 hydrogen. Oxygen. 1, 2, 3, 4, 5, 6, 7. Okay. Yep. So answer is A. Okay. 28. Okay. Which reaction occurs when ethane and chlorine in diffuse sunlight? Okay. So alkene plus chlorine, sunlight, UV. This is definitely free radical substitution. Definitely. Okay. When there is UV light, is free radical substitution. Okay. But what is the product? Okay. What's the product? The product for the free radical substitution is which one? Okay, let's check quickly. Okay, free radical substitution. Okay, not this one. Yeah, free radical substitution, the product. Okay. Um, yep. Okay, yeah. Okay, what kind of products we will get? Okay, the main product, HCl. Yeah, okay. So here hydrogen given off, no. Okay, no gas given off, no. Hydrogen chloride given off. Okay, so we have hydrogen chloride. Okay, one of the products. Okay, so answer is B. Okay, next. Okay, molecule of geranium. Excess cold dilute acidified manganate. Okay, we remember this one. This one is adding the dio. Yeah, so it's adding dio like this. Okay, when we have cold dilute acidified. Okay, cold dilute acidified. If we have hot concentrated manganate is breaking the double bond. We are splitting the double bond. But when we have coal, we are adding the alcohol, two alcohol groups. Okay, so the answer will be A. Okay, answer is A. Okay, next. Okay, Q is either a primary or a tertiary halogenal alkane. Q undergoes hydrolysis with aqueous sodium hydroxide. Yep. Okay, Q. So like, let's say this is Q, like something like this. Okay. Some kind of halogenal alkane. Okay, undergoes hydrolysis with sodium hydroxide. One, two, three, four. 2, 3, 4, 5. Okay, so which means is a nucleophilic substitution. Okay, so we are substituting the Br with the OH. Okay, the first step in the mechanism involves two species reacting together, means SN2. Okay, SN2. We need two species reacting together is SN2. Okay, so SN2 is always for primary. Okay, SN2 is always for primary. So our answer is this one. Okay, behavior of the hydroxide ion, because we know this is nucleophilic substitution. Okay, nucleophilic substitution, so it must be a nucleophile. Okay, so our answer is B. Okay, just in case, let's quickly review this. Two species reacting together is SN2. Two species reacting together. Okay. Okay. So this is the part we talk about the SN1 and SN2. Okay. This one is SN1. Why? Because it got three groups. Three bulky groups. Okay. Three bulky groups. It's very difficult for the OH to come. It's too crowded. Okay. So the OH does not come, and then it just break the Br first, and then we have this tertiary carbocation. This is SN1. So we don't need like we only need one molecule to start the reaction. We just need one molecule to start the reaction. Okay. And then now the nucleophile comes along. Okay. And then we form the final product. Okay. Okay. So this one is SN1. This one is SN2. Okay. So this is SN2. It needs two molecules to start the reaction. It needs two molecules to start the reaction. Okay. You see, this is primary. Okay. This is primary, so it's not crowded. Okay. So this is not crowded. So as the bromine is leaving, okay, the OH is coming along. It's coming along. So we have two molecules to start the reaction. This is the first one. This is the second one. Okay. So we need two molecules to start the reaction. So at first we have this. Okay. So this is our starting molecule. This is our starting molecules. And then the hydroxide comes along. Okay, the nucleophile comes along. So it formed the transition state. Okay, and then the bond forms. Okay, and then in the end, we end up with our product. Okay, so we can see the product, both of them, they are substitution, but this one the Br will leave first, then the hydroxide come. This is SN1. We only need one molecule to start the reaction. We need the Br to leave first, okay? The hydroxide comes later. SN2, we need two molecules to start the reaction. We need the bromoalkane and the hydroxide. We need two molecules to start the reaction. This is why we call SN2. Okay? Yeah. So that's the idea. Okay? Yeah, that's why we are saying SN2 is for primary. Okay? This is a primary halogenal alkane. This is a tertiary. Okay, halogenal alkane. Tertiary always prefer SN1. Primary always prefer SN2. Okay. Okay, let's do one more question. Okay, this one. Okay. So we are starting with bromopropane. Bromopropane like this. Okay, bromopropane. Reaction 1. Okay. Okay, bromopropane, and then suddenly it become 1,2-dibromopropane, which means we must have elimination here. Elimination, okay, which gives us the alkene. And then the alkene, it becomes 1,2-dibromo. So which means we are adding the Br. Okay? We are adding the Br. Okay? So which means this one will be electrophilic addition. Okay, so reaction 1, what we want? We want the condition. Condition elimination must be ethanolic sodium hydroxide. Ethanolic sodium hydroxide. Okay, so now we are adding 1,2-dibromo. So we are adding both bromine. So we must have Br2. Okay, we must have Br2, not the HBr. Okay, because we are adding both side Br. We are not adding HBr. No. Okay, we are adding both side Br. So our answer should be D. Okay, yeah. Okay, the time is perfect. We can stop here and then continue next time. Okay, yeah. So next week I will prepare more past exam questions for the organic chemistry to go through together. But at any point you want to change another topic or you want to start the A levels topic, we can also do that. Okay, but in the meantime, okay, we will continue this organic chemistry revision. Okay, yeah. As usual, I recorded the class. So if you want to come back and check again the explanation, you can do so. Okay. If no other question, we will stop here. Okay. Thank you. Thank you. Bye bye. Bye bye.